Hello, welcome everyone. Welcome to this session on threat hunting with Jupyter Notebooks. My name is Ian Helen. I'm a developer in the Microsoft Threat Intelligence Center. I work as part of the Azure Sentinel team.
And I'm Maarten Goed. I run the Enterprise Security Unit for Wortel, and I'm a Microsoft MVP and Regional Director since a couple of years. I've been working on security quite a bit.
Okay. We work together quite a lot on recently in Azure Sentinel. Occasionally, if you've seen any of our tweets, we occasionally double as like a Batman and Robin. But we forgot our costumes today. So.
Got a suit.
So some of you, I hope, have seen some of the, either been at the Azure Sentinel stand or seen some of the talks describing some of the features in Azure Sentinel. There's a lot of like richness in there for detections, hunting, investigation. So why would you think about using Jupyter Notebooks? Why is this a kind of an option? I think there are three big areas that are Jupyter Notebooks brings something extra to the party. So the first one is the availability of additional kinds of visualizations, data analysis libraries that, for one reason or another, and probably never will be part of a core Azure Sentinel. And we'll look at a few examples of some of those. The second thing is it's very easy to bring in external data. So data that you may not have within your Azure Sentinel tables, your Azure Sentinel workspace. Might be external threat intel data. It might be on-premises, very sensitive data. It might be some public data that it's too big to ever bring into to log analytics tables. You can join that with your hunting data within a notebook. And the third area is a bit more kind of intangible, but it's about managing complexity. So maybe even if you only do queries, like a set of queries, I want to talk about like how Jupyter Notebooks can help you manage an investigation that's more than about 3 or 4 queries. And it's a kind of a useful container for keeping all of your investigation-related data together. Can I do like a quick show of hands? Is anybody here using Jupyter Notebooks? So a few people. Anybody here not know what Jupyter Notebooks are? So there's a couple of people as well. So I'll give you a demonstration in a moment. But it's easy to be daunted at first look of a Jupyter Notebook. There's a lot of code, some kind of like complex looking visualizations. It's important to remember there are different kinds of use cases. So I think they're very useful for a very experienced investigator doing ad hoc hunting or investigation. I think they'll also have another use for maybe like SOC engineering, for building replayable notebooks. And the audience for that would be maybe tier 1 analysts who might not understand how to write the code to do this analysis, but they can execute a notebook, execute a pattern of investigations and benefit from them. And because Jupyter Notebooks are like a displayable format, you can show it to people who will never understand code at all, like people like our managers. Okay. So how do we get started with Azure Sentinel and Jupyter Notebooks? There is a little icon down the side of the screen where it says Notebooks, surprisingly enough. And we've partnered with Azure Notebooks that's a Jupyter Notebooks as a service in Azure Cloud. So clicking on this will take you to a list of some of the notebooks we've got available. You can either go straight to your Azure Notebooks account, and if you don't have one, one will be created for you as part of that workflow. Or you can clone, which is probably the starting point, you can clone a copy of our existing notebooks we've published on GitHub using the button kind of near the top of the screen. So this will give you a new Azure Notebooks project that's pre-populated with a set of notebooks. And now I think we will switch over to look at an actual notebook. So for those of you who don't know what Jupyter Notebooks are, they're a kind of a client-server model of the there's a part that runs in the browser. It's a very clever bit of JavaScript, an HTML code that gives you like a text editor, really like an intelligent code editor where you can type in code. It's usually Python. That's the most common language, but there are many, many languages supported by Jupyter. There's an execution engine which can be running on your own machine, or it can be running, in the case of Azure Notebooks, it would be running in the cloud somewhere. So when you, and I'm going to take my life into my hands a little bit with the network here. If you remember that graph with a big spike, like try and keep focused on it, because if this query doesn't work, then that might be the last time you ever see it. So what I've done is sent that query over to the kernel, over to my my Jupyter Notebook server end. It's executed the query, it's brought back the data, and it's rendered this graph. And something you might know if you're familiar with Azure Sentinel is this section here is just a standard KQL query, and you could copy and paste that from the Azure Sentinel kind of log exploration and paste it into here, and it will work identically. If we scroll, not using my finger, down the screen, whoa, we can do another more familiar data query. This is very simple. This is showing the count of by logon type of the different logons on that we saw in that graph. So these are not very interesting queries, but what I wanted to show you here is, if I scroll back, like unlike most query environments, we not only have captured the query that we ran, but we've got the data output, and that will stay there forever, or until you come to delete it. So even if all you do in Jupyter Notebooks is run a set of queries, it's a really useful environment for managing that complexity. You can go back and see what you did before, you can make changes to them, rerun them any number of times. Of course, you can do other things in Notebooks, and some of those I want to show you, because I think there are other benefits as well. So I talked about like visualization and data processing libraries, and we'll look at a couple of those. So this is something that's a kind of a really key tool in the I guess in the toolkit of most investigators is a timeline view of what's happened. So this is a view of logons on a host over a period of days. It's divided into like it's shown the horizontal rows are the logons for each account type, or sorry, each named account. And as we move over the things, we can see a bit more detail, like the origin IP, the logon type, and it's also interactive, so we can get rid of like stuff that we not so interested in, and we can zoom in to see individual accounts in kind of great detail. So you're able to like use things like this to drill in on very fine detail of like the case you're investigating. Another example, and again my screen scrolling won't work. This is more of an example of data processing rather than the visualization is a little bit crude here. But what we've done is taken all of the processes. So we've seen all of these different logons, but which one do we want to look at in more detail? So one way we can do it is look at the processes that are running in each logon session. And here we've taken all of the logons over a period of multiple days on a host. We've applied a simple machine learning called clustering, a machine learning technique called clustering, to group processes into like similar behaviors. So similar processes, similar command line patterns. And the ones that are repeated very regularly will group into one cluster. The other rarer ones will group into smaller clusters. So we can use that cluster size to get as an indication of how rare a particular process execution was. And what we've done here is then computed the average rarity for each of the process sessions. So we can see right at the top, this character Ian has got the most unusual kinds of processes, whereas way down at the bottom, for our system logon sessions, we can see thousands and thousands of processes that are all essentially very repetitive and uninteresting. So here, this would be a good indicator that the top set of these sessions are the ones we want to start looking at. Right, I need to speed up a little bit. So another example of of bringing more advanced data processing in notebooks is extracting difficult to get at data. So here, if we look at this process, you can see at the bottom the command line here has got this encoded block in it that makes it very difficult to understand exactly what's going on. This is a common attacker technique to encode, obfuscate their intent by base 64 encoding, or in sometimes like multiple encoding, like zipping a command or zipping a binary, then base 64 encoding it. We can use one of our libraries to decode that. And here we can see inside that it's actually a HTTP request that's pulling down what looks like a JavaScript file, but it's actually been saved as a local executable file. And we notice in there are interesting things like IP addresses, a URL, file path. We could copy and paste those. We might want to go and analyze those or submit them to some threat intelligence service. We could copy and paste those things. But imagine we had 1,000 of these processes. That would be a really onerous kind of task. So we can use another library to pull out the individual IOCs in there, the indicators of compromise. So we've got our IP address and URL separately, and can then submit them to a threat intelligence, or in this case, an array of threat intelligence providers. This could be the Azure Sentinel built-in threat intelligence, but we've also got drivers for Alien Vault OTX, for VirusTotal, and these give us a verdict on whether we can trust these things or whether they really are something bad. And we can see that one of them, the URL here, is some kind of exploit kit. So we've done some drilling down into, gone into kind of showing you some examples of data processing, visualization, bringing external data in some depth. I'm going to hand over to Martin now, who will zoom out a little bit and see although we can drill in micro detail, can we get a bigger view by looking at other kinds of external services?
Thanks, Ian. So Ian had been looking at data that's coming from Azure Sentinel. And we want to get the bigger picture on, here we go, on all of the signals that we get from our environment. And one of the ways to look at this is start using the Microsoft Graph Security API. It's a RESTful API that aggregates the alerts and the signals that you have coming from all of your Microsoft security services. But it also supports other third parties and can aggregate those signals from those vendors back into one place, one stream of data that you can have a look at and work with. And let me show you. Can you switch to number 8? Yeah. So what I'm doing, instead of using the web Jupyter native front end, I'm actually showing you Visual Studio Code, because with the October update of the Python extension, there's now native Jupyter support, and we can work with the same backend and with the same data from Sentinel, Defender, and the Security Graph API. So what I'm doing here is using my Anaconda environment, logged into my tenant, and working with a Jupyter notebook that I've already prepared. And this one actually looks at the Security Graph API, and that is the same graph that you already know and love from the Office 365 world and the Microsoft 365 world, but then specifically for the security alerts. Now in Defender, I have an alert standing by that is telling us that we found a suspicious process injection in one of our endpoints. And if you go into the Graph Explorer that aggregates signals from Defender, from Cloud App Security, from all of our security services, we can actually query the graph by going to this query, /security essentials, essentially. So we say we want to get all the security alerts, and in my case, I'm filtering on Defender ATP. We run it and we get JSON back. In this case, it says, well, a process abnormally injected code into another process. So we find the same alert that we have in Defender A2P now programmatically, and that is something we can work with. So switching back to Visual Studio Code, I run the same cell, I authorize and get an access token, I build up my web request, and essentially I'm querying through the same method here, through the Graph API, and I want to get back all my Defender ATP alerts or anything that I'm looking for. And if I look at the JSON, I can see that it is a PowerShell exe that has been injected into a notepad, and there is a host involved called SOC with my name in it. So something is happening there that we need to have a look at. Now if we go to Defender, Defender will give you already a lot of advanced hunting capabilities. If you want to pivot through this data and want to look at what's happening for the suspicious process, I can just drill down into the interface. I get details on this PowerShell exe getting injected into Notepad. There's information about the Mitra TTP that is likely to be involved, and we can click from here and get more information. And the web UI will already give you these advanced hunting capabilities. And for instance, I can run information on this endpoint and get all the network communication that has happened, and use the KQL code. Let me rerun. And get information back on the results of all the network communication happening. Now this could be a data point in our ongoing investigation that we want to pivot on. So let me pull up a second Jupyter notebook. Again, we need to get an access code, or an access token, I'm sorry. And I'm using the same KQL we just saw in the Defender ATP portal, but we'll now use it programmatically. So I'll run the query, and then there is something that is called the Advanced Threat Hunting API that Defender exposes that we can run the query against, and we get JSON back. If we print that in a table, we get all the connections from the IP addresses from this machine and see which process is connecting where. Now with the toolkit that Ian had been telling about, we can do Geo Lookups. So we can take this IP address and understand where, in which region does it live, from which provider does it come. And if we run this piece of Python code, we actually do a Geo Lookup for each and every IP address in this table. We get a latitude and a longitude back, and I will start drawing a map around the Orange County Convention Center, and we can get a list back of all the processes and the locations that we're connecting to. And we can say here, this is where we are today, but we see, for instance, a process on the West Coast. So apparently Docker is hosting their services on the West Coast in a data center. And we can start to understand anomalies through a cognitive way. For instance, one that is all on the east that we could start inspecting. Now another neat trick, instead of looking at table data, is to look at a graph version of the data and really use our cognitive skills to find information in this pile. And so we use an extension called Graphistry that builds a hypergraph. It takes all of the data, it starts understanding the relationships, and it groups essentially all the data. And even if I don't know the data, what I'm looking at too much yet, it gives me at a glance information about these processes are quite dominant, and we could filter down and say, well, which IP addresses are involved and which processes are connecting to those. So there are a lot of ways that with extensions and through a Jupyter notebook we can get more insights. And then, for instance, we could use an extension to write our root cause analysis back into a Word document. We generate the information we just found through Azure Sentinel, through Defender, through the Graph API, back into something that we can then send around. But I guess showing a Word document might not be the best way to share our information. So are there other ways we could do that, Ian?
There are. So if I'm flipping back, I'm sure you're all very familiar with PowerPoint, and I've used it for many, many years. I'm not going to show you anything in PowerPoint here, but I am going to show you very quickly in wrapping up that you can use a Jupyter notebook I think you can use a Jupyter Notebook as a kind of substitute for PowerPoint. So many of the things I showed you before, if you can imagine you've done an investigation, you've got some conclusions, you want to present it to co-workers, to management, you can just flip into presentation mode. The nice thing about many of these things via Flip, that it retains the kind of interactivity that in the notebook, but in a kind of a presentation format. So most of these things are, or many of the things that you've seen are kind of built into a tool set that we created, a Python tool set called Mystic Pi. The basic idea behind it is it really is turning this in your Jupyter Notebooks into something a bit more like this. So rather than big blocks of code that's kind of repetitive, you have to write. There are many hundreds of lines of code behind this particular visualization, but you don't want to have to write those every time you want to see a graph. So here is like a single line that does the query and another line that does the graph, the graph parameters. I'll summarize and zoom out a bit so you can see everything on there. So Azure Sentinel gives you a lot of stuff as it is. It gives you a lot of like cool investigation experience, the ability to run arbitrary queries, this huge kind of Elasticsearch database that it's based upon. Sometimes for more advanced scenarios, Jupyter is your friend, like to be able to step outside that, to be able to use the kind of the power of Azure Notebooks, and particularly to do these three things, to kind of like help you manage complexity with a whole set of queries that are grouped together, to be able to bring in more advanced visualizations, data analysis tools, and to join external data from other sources into your investigation. Azure Notebooks, as I said, is also our friend with Jupyter. That's the kind of tightly integrated with Azure Sentinel to give you an easy route to execute, whether you have Python installed locally or not. It's easy to execute the notebooks in Azure Notebooks. And I would say, like, essential skills, certainly KQL. You know, if you're going to do any hunting in Azure Sentinel, you need to understand the query language. And I would say almost as essential, if you're going to do a little bit more, is like at least some basic Python skills to be able to use some of these advanced visualization tools. A call to action. Well, try out the notebooks. Please give us feedback on, we've got multiple samples in there, also kind of, readily usable notebooks. There's like an IP Explorer, Host Explorer, Account Explorer, and they're meant to be used, like if you're in any doubt about what's going on with this particular host, you can run the exploration notebook and it will give you more details, more kind of advanced stuff. And watch, there have been many really great Azure Sentinel presentations at Ignite. I would urge you, it's too late for me to refer you to ones in the future because they've all happened in the past, but go to the Ignite portal and search for Azure Sentinel and you'll find those sessions there. Some additional resources. So Martin and I are going to post the location of the notebooks that we've been using next week on GitHub. We're going to post them on Twitter, so you might want to follow us if you're doing that. Here are some other references. So the Mystic Pi location, where our Azure Notebooks, our Jupyter Notebooks are located on GitHub. The Azure Sentinel Tech Community blogs down the bottom is a really important place to go, and Azure Docs that gives you a basic introduction to using Jupyter Notebooks with Azure Sentinel. And I'll leave that on the screen. I think we're probably overrun for questions, but we'll certainly be around for as long as anybody wants to ask us anything after the session.
Perfect.
Thank you very much.
Thank you for attending.